All right, we'll try this again. So this is the other side of this worksheet that you guys were looking at today in class. And some of us got started with writing some of these equations down. So I wrote down all the equations that you should have, although you probably wrote them in different orders. And you might have switched them around sideways or something. But I got log 3 plus log 8 equals log 24, log 7 minus log 2 equals log 3.5, etc. Throughout this whole collection of things here. So hopefully you got the same equations that I did, even if you put them in a different order. And so then I went ahead and, like it's suggested here, used a different color or highlighter pen to kind of group the different kinds of equations together. And I noticed that some of the equations had a sum of logs, like this one and this one and this one. There was some log of something plus log of something else was part of the equation. So those three were kind of in the same category. And then there's other ones where it was subtracting something. So like this one, there's a difference, or here we go, here it is, the difference. Log 7 minus log 2, or log 4 minus log 5 equals something. And so here's all these different ones that have a subtraction of logs going on somewhere in the equation. I got some fractions, I got some whole numbers, got some decimal, and stuff like that going on. Okay, so then there was a third group of equations that didn't have subtraction or addition, but they had multiplication. In other words, I was multiplying a log by something, and so like a 2 log 4 or a 3 log 5, there was 1/2 log 7, 0.25 log of 67, or a 7 log 10. All those equations had a multiplying going on in the equation. And what I noticed there is that I can group these together, even though this one seems a little bit different. But for example, I have log of 5 to the third on one side, and I have 3 times log 5 on the other side. That's very similar to this one over here, where a natural log of 10 to the 7th power equals 7 times natural log of 10. It's kind of like that exponent there is multiplying, just like it is here. And over here, it's the same deal. There's the exponent, and it's multiplying. That works in these cases as well, because even though this says the square root of 7, I can think of that as 7 to the 1/2 power, or writing it as 7 to the 1/2, right? And so then there's my exponent of 1/2, and that again is multiplying this log of 7. And even here, the 4th root of 67, well, that's like using an exponent of 64 to the 1/4 power. And of course, that's 0.25 is the same thing as 1/4. So it's the same kind of a deal there. 67 to the 1/4 power here is 1/4 times natural log of 67. Okay, and then these two guys right here, they're kind of out on their own, but these are just saying something that I know is obviously true. For example, I know that natural log uses a base e, a little e there, we never ever write it, but there it is, kind of sitting there. And that if I use that snail pattern, this means the base e to this exponent equals this value right there. And e to the first equals e. So that's just kind of an obvious identity there. And the same thing is true here, although you might not be as familiar with this. This log, when there's no number written, log by itself means log base 10. So it's kind of like there's a little hidden 10 right there that we never ever write. Actually, they do write it sometimes in our book, but in a lot of books they don't. So log base 10, all right, 10 to that, there's my base, 10 to this exponent of 1 equals 10. 10 to the first equals 10. So these things are kind of like little identities that are true and saying kind of something that hopefully is somewhat obvious. Okay, what I want you to do right now is to look at the other video that's posted alongside of this, and that will summarize some of these properties of logarithms into general rules that you will be able to use. Okay, thanks for watching.